This is still 10-1, and we're still dealing with absolute value functions. And now we're going to move into a number inside the absolute value. So you're going to sketch it. So I'm going to go -3 plus 2, which is -3. And I'm going to add 2, which is 1. -2 plus 2, which is 2 plus... Oh, inside. And -2 plus 2 is 0. -1 plus 2 inside absolute value is 1. 0 plus 2 absolute value is 2. 1 plus 2 absolute value is 3. 2 plus 2 absolute value is 4. 3 plus 2 absolute value is 5. Going to do 0, 2, and then -3, 1, -2, 0, -1, 1, 1, 3, 1, 4, 2, 4, like this. And so this is common that the +2 actually moves left 2 units and has a minimum. So it's going to be common because this is going to come up in circles, it's going to come up in quadratics again. So anytime a value is next to an x and it's protected somehow, and this way it's protected by the absolute value, it is doing what to me in my head says opposite of what I would think. I would think, oh, moving right to it, and x doesn't do it. X moves, this says it moves left 2 units. Likewise, we're going to see that this is also in the absolute value and it's protected, and so my prediction is going to be right 2 units, and it's still going to have a minimum because remember, the only thing that makes things have a maximum is a leading negative. So we're going to do -3 minus 2, which is -5, and absolute value is 5. And then I do -2 minus 2, -4, absolute value is 4. -1 minus -1 minus 2 is -3, absolute value. And then 0 minus 2 is -2, absolute value 2. 1 minus 2 is -1, absolute value 1. 2 minus 2 is 0, absolute value is still 0. And 3 minus 2 is 1, absolute value is 1. And so here's where your minimum is. This is where this will be repeated, so I could predict that this is a 2, a 3, a 4, a 5. So when I graph it, 0 is 2, and then -3 is 5, 4, 3, 2, 1, 0, and indeed, inside a parenthesis, a minus moves right. Moving on, you're going to have to be able to predict what's happening. So negative outside an absolute value causes it to be a max. It also says I'm going to, and this is an up 2. So I'm going to put my max, and I'm going to come down the diagonals. So my vertex is at 0, 2, and it is a max. The negative outside an absolute value means I'm going to have a max. It's going to look like that. And this says down 2. So I'm going to take my vertex and I'm going to move it down, and it's going to be reflected, so it's 0, -2 with a max. Negative outside the absolute value causes it to have a max. Inside, protected by an absolute value, is in a left or a right. I think it should go right, but it's going to go left 2. I'm going to go left 2, and I'm going to do a max. And so my vertex is at -2, 0 with a max. And you are going to have to be able to look at an equation and explain whether it has a min, a max, and where the vertex is. So a negative outside the absolute value causes it to be a max, causes it to look like that. Protected by absolute values close to an x does opposite of what I think it should do. So I think it should go left, so it's going to be go right 2, 1, 2, going through the diagonals. My vertex is at 2, 0, and it is a max. The graph of all absolute values are in the shape of a V, whether it is right side up or upside down. So we have these and these. So here we go. What does this do? This moves up. What does this do? Moves down the vertex and everything that goes with the vertex. Inside, a plus h moves left. And this h and k, they're going to use these again when we go into circles, or when you go into circles. And then minus h inside a absolute value moves right. If you have a negative sign in front of the absolute value, the graph will be, you can say flipped or reflected, however you want to say it, over the x-axis, and so it's going to look like that. Here we go. Positive, going to look like a V, -2, right 2, minimum, down 4. And you have to be able to say all three of these things. And your vertex is going to be at this, but notice it is 2, -4 for your vertex, and it's a minimum. So I go to 2, -4, and then I graph it. If you do not know how to read it, you will have to make a table and then graph all of your points. Okay, negative outside an absolute value makes it a max. Positive 3 inside an absolute value causes it to go left 3. A positive 1 outside the absolute value causes it to go up 1. My vertex is at -3, 1, because x doesn't do what it looks like it should do, and it is a max. So I go -3, 1, and I come down the diagonals. Again, if you can't do it from the equation and reading it, you can create a table and do it that way. You will be, one of your requirements will be to say, describe the transformation from the parent function, which is it's a max, it moved left 3, it moved up 1, and its vertex, and you're going to have to tell the location of the vertex. That finishes 10-1, absolute value functions.